I really think I need a theme song for these videos. I mean, they're kind of dry. I mean, but a theme song would be nice. Mr. Samita's absolutely wonderful videos of him on OneNote. That's pretty weak. I got to come up with better. If you got better ideas, I'd love to have them. I mean, I have a home studio, so I could even whip up something that's kind of, cheesy that I can just play over the top of it. So, we'll see. Again, this should not be a priority. I mean, I give you enough work now. We're going to do some non-equilibrium situations. In these cases, the sum of the forces does not equal 0. It equals MA. Nothing terrible. But some of the problems can be kind of complex. And I wanted to look at a few of them. Again, you need your textbook. So, you should have it out. We're going to look at page 160. We're going to do 3 problems, I think, together. Page 169. We'll start with problem 5.18. There are 3 sleds, as you can see in the picture. Let me draw my... Oh my God, that is a horrible sled. And then there's some force pulling them forward. Okay. And they want to know the tension on each cable. They call this A and B. And they tell us that the pull is of magnitude 125 newtons. Remember we did a problem where we had 2 blocks on a rope and they were hanging upward. This is kind of like an easier version of that problem, because we know the sum of all the forces is going to equal MA. So what I did first is I said, okay, well, the total external force, this is the total, the net external force is going to be 125 newtons, because that's all you've got. Because that's all you've got from the outside. I mean, pretty much these are all pulling on each other. Those are internal forces. So in this case, to find first we got to find the acceleration of the whole system. In fact, they ask you to do that first. That's just going to be the sum of the forces over the mass total. Which in this case, let's see, this is 30 kilograms, this is 20 kilograms, this is 10 kilograms. So it's going to be our 125 newtons divided by 30 plus 20 plus 10. That's 60 kilograms. So 125 divided by 60. It's got to be 2 point something, but let's make sure. 125 divided by 60. So okay, 2.08. 8 meters per second squared. And we're going to need that for all of the other tensions. And it kind of makes sense. So what we're going to do is they want the tension on A, which means we're going to look at boat A first. That one we're going to have a free body that has the force pulling forward, and it's going to have TA, no snickering, backward. Of course, we want to make sure we have all the forces labeled. So it has mg forward, and it has a normal force backward. It tells us that it's frictionless, so we don't have to worry so much about it. And since it is accelerating forward, I did try to make that one a little bigger than that one, though I think I could have done better in that. So in this case, we know that our force is going to, we know that our net force equals MA. Okay. So I'm going to have 125 newtons minus tension of that equals MA. Okay. Well, I'm only really accelerating one thing forward, and that's this boat. So it's 125 newtons minus TA equals 10 kilograms times A, which we figured out from up there, is 2.08 meters per second squared. So this is 20.8 newtons, 125 newtons minus TA equals that. So we end up with 104.2 newtons equals A. Okay. So I will say I will have a third problem. I will have a couple more problems for you in just a second.